Hello. So, for those of you who are new to this class, my name is Mr. Palacios, and we're going to get started. Right here, what I want you guys to do is I want you guys to take notes. Make sure you guys are writing all of this down. Uh, we're going to do this in parts, in sections, and every day you're going to have to take notes, do the problems for that day, do the warm up, and we'll do that pretty much for 4 days out of the week. So, with that in mind, these are your vocabulary words here. Let me see if I can just, all right, so your well, what is that? Okay. Yeah, so these are your vocabulary words right here. We're in Algebra 1B, and you're going to need to know what these vocabulary words are. Make sure you have them written down in your notes for today in your notebook or in a loose piece of paper, wherever you're doing this, because you're going to take a picture of this and you're going to upload this uh, into Google Classroom for partial credit. Now, the vocabulary is not the only um, it's not the only notes. You're gonna have to write down all the examples. Okay, so just keep that in mind. Why don't we start with exponent? Exponent is a number that says how many times you need to multiply the base of a number by itself. For example, 9 raised to the second power. So I'm gonna be throwing a lot of vocabulary words at you. So if you get confused, it's okay, right? What I'm talking about is 9 is a regular number, right? An exponent is usually shown like this. It's a smaller number that's on top, right? And this right here is your exponent. Okay, I don't know why it's doing that. Okay, exponent. Okay, so that 2 is your exponent. And pretty much what that's saying is, it's saying that if the 2 is the exponent, the 9 is what we call the base, right? And what it's trying to say is if something is being raised to the second power, because another word for saying exponent is the word power, right? Then what that means is 9 is being raised to the second power. 9 is being multiplied by itself exactly 2 times. So I know it can be a little confusing, but that's pretty much all it's saying. If I had a different exponent, like let's say I had 9 raised to the third power, that it's not 9 times 3. What it is 9 times 9 times 9, which in this case would be 27. I don't know why that keeps popping up on my computer. Let's see, erase line, okay. Right, so that's an exponent. Now, the next vocabulary word is radical, and radical is the opposite of an exponent. Pretty much whatever it is, like for example, here we have 9 to the third power. We have an exponent, right? It's this little house looking symbol, like the number inside the house looking symbol is going to be your base, right? This is the number that everything is being done to, right? This is your base. And this right here is your root, your square, your cube root, your square root, whatever you want to call it. Let's see if I can just erase that. I don't know why it's doing that. Okay, so and that tells you how many times. So right here, it's the opposite. So what you have to do here for a radical is you have to look at the base. You have to look at the number that's inside that little symbol, and you have to ask yourself, okay, what are the roots of this number? In other words, what number can I multiply by itself this many times, right? So in other words, 3, so they want 3 numbers that multiply by themselves, by itself, that'll give me that. Now, there really isn't any number that I can multiply, right? That'll give me that. However, if this was a 2, right, then that works because what ends up happening, right, is that 3 times 3 would give me 9. The cube that you can find the cube or the cube of a 9 is just going to involve decimals. All these problems are solvable, but you would need a calculator to solve the ones that aren't perfect squares or perfect roots, right? We're going to be dealing mostly with perfect roots, which means that all the numbers I'm going to give you either in your practice or in the class are going to involve perfect roots for now. All right, so a radical expression. We're now down to the next one. A radical expression is an expression that contains a radical symbol. Notice I have n root a. That's just a way to separate kind of like what's going on, like, right? The n in that case would be another word is called the index. I just call it the root. Whatever you want to call it, it's the number that's going to tell you what to do, right? The A is the radicand. Now I know I'm calling it the base. There you're gonna see a lot of different terminology. Like for example, if you look up these terms on the internet, you're gonna get you're gonna get a bunch of different terms, and most of them are correct. Um, but I'm just gonna try to expose you to as many different vocabulary that I can because this is a 5-week course, and that means that we're not gonna have enough time to go over everything, right? So we're gonna try to cover as much as we can, and we're gonna move on from there. So, uh, right. So what is a radical expression? It just this whole thing is a radical expression. This whole thing is a radical expression right here. It's just it's something that involves a radicand. It's something that involves a root. Something that involves this symbol, right? With either this or maybe a power here. It's just like it's like a unit of numbers that are together that involve specifically a radical, right? All right, a radical exponent. Any integer as n is greater than 1, the nth root of a is a number that, when multiplied by itself n times, is equal to that. In other words, radical exponent is just really what it's trying to say is there's a way that you can change. There's two different forms for radicals. It's something called exponent form and something called radical form. That's like kind of like the textbook definition, and I suppose it's useful for you to know, but it's very confusing, right? Like if you were to look up that definition online, most people would look at it and be like, I don't know what this is saying, right? Because it's confusing. Really, what it's trying to say in easier terms is you can go back and forth between two different forms, right, to express these expressions, right? So I'm going to call your attention down here where it says exponent form to radical form. I have a 4 squared. Whenever we have a power or an exponent shown and nothing else and just a base and an exponent, that's what we call exponent form right here, right? That 4 squared is considered exponent form. However, I can change that to radical form. And what I do is I'm just rearranging the numbers to include a radical. Now, you might be thinking, why do I need to know this? You need to know this because depending on the complexity of the problem, you might have to deal with either an exponent or a radical, right? And you need to know how to toggle between these two, mostly because you're going to be dealing with fractions. And if you can have the same radical on the top and on the bottom of a fraction, they just cancel out. It's like a shortcut. Or if you have the same exponent on the top and on the bottom, the exponents have their own rules, right? But generally speaking, you want to be able to go from one version to another depending on whatever the problem is asking you to. So in this case, right, we have a power and we have a base. If we're going to turn it into radical form, right, in the radical, we have the radical symbol. The base goes inside, right? This is still the base, and that 4 is still the base. So notice the 4 is still at the center of both forms. The 2 is the one that switches places, right? It used to be the power right there. Um, oh, sorry. That's supposed to be 1/2. Um, if something is raised to like a 1/2 power, it's an exponent, right? But it's part of an exponent. So if it's part of an exponent, you can turn it into radical form. And what I mean by that is the top part, I want to draw your attention kind of like right here, where it says the power, the numerator of a exponent, right? That of the exponent would be the power, and the denominator of the exponent would be the root. I know that's confusing, but just know that when you're changing it from exponent form to base form, the denominator goes on the outside of the base, right? This used to be your denominator, right? And the numerator technically is there. It's like right next to the base, anyways. Um, but in this case, because it's 1, you might not see it. You'll see this written on some of the problems. They'll often forget to put the one. It's not really that they're forgetting. It's just that whenever we have a one as an exponent, we tend to not put it there. We tend to ignore ones a lot as a way of just saving time. But just know that they're always there. Like if a number is there and it's by itself, it has a power of one, pretty much. But we just instead of writing the one every single time, we just ignore it. Um, so, anyways, right? You can do this with any exponent, any number that has an exponent that has a fraction on it, and even the ones that don't. Right? For example, like in the original, I had 4 to the power of 2. This is technically a fraction because any whole number can be made into a fraction by just putting a one on there. The one in this case would be a root, right? Let's okay, let's just get rid of that like this. The one would be the root, and then the two would be the power, which means if I were to change this into radical form, right? The two goes outside of the radical, right? Because the power, the I mean the let's see, yeah, okay, erase that. Okay, technical issues. Let me just okay. Okay, well, it's not letting me right now, but pretty much we can always rewrite it into a radical form either way. So you're going to be doing this going back and forth. You can also go from radical form to exponent form, right? You just have to remember which one's your power and which one's your root, and you can change it, go back and forth. With that in mind, now we have negative exponents, right? So for negative exponents, we have the example right here. Okay. We have the example right here for a -2, which equals to 1 over 4 positive exponent of 2. So what's going on here is negative exponents have a special rule to it. The rules that I'm going to introduce are shortcuts, and we're going to go over more about what the rules are next week. For here, I'm just kind of giving you a crash course of what is going on. And then next week, we're going to go into the nitty gritty of why everything works. But for now, just know that the rule is whenever you're dealing with a negative exponent, what you have to do is you have to convert your base into a fraction if it's a whole number. If it's already a fraction, all you do is flip the numerator and denominator. So for example, here we have a base of 4 and a -2 as an exponent. It becomes, right, every time we have a whole number and we need it to become a fraction, we can just put a 1 underneath it. So this 4 raised to the -2 power is the same as saying 4 over 1 raised to the -2 power. What's going to happen is that 4, that numerator of 4, -2, is going to switch places with a denominator of 1. And you end up with a fraction, 1 over 4 squared. But after you flip them places, right, the negative is canceled out. It goes away. There's an actual process for this, but we'll get into that a little bit next week. But just know that this is the rule for now. So whenever you see that, that's what you're going to have to do. It can be a little confusing and complicated once the problems get more complicated. So for example, um, right here, right, like in this one, where we have 4 and a -2/3, what do you do there? Well, it's pretty much the same thing. You're just going to put a 1 underneath that, and then they're going to flip places, right? The numerator and the denominator are going to flip places. So the 4 and the -2/3 are your numerator, and then they'll go down to be your denominator. So they flip down here, right? So, and then you flip it up. And all I did was I transitioned them, I turned them into radical form because you'll see this. You'll see where the problems go from one form to another. And you're going to have to know that you have the option of changing them whenever you want. So in this case, you notice there's no negative on the bottom. The negative's gone because you flipped them. You flipped them places. Okay. What happens if you have a parentheses? We're going to go over this at the end. Probably it won't be day 1, but around day 3 or so, or we're going to be going over this. So when you have a fraction and then you have negative exponent, what you're going to do is you're going to want to distribute the negative exponent to the numerator as well as to the denominator, right? So that 1 gets that -3, right, as shown here, and that 4 gets the -3 as shown here. They each get the -3 exponent. And since they each have a negative exponent, we're not allowed to keep that negative exponent. We need to turn that negative exponent positive, and we do that by flipping them places, right? That's the shortcut. So the 4 thirds goes on top, and the 1 to the third power goes on the bottom, on the denominator side. And then that you would just reduce it further. Um, so 4 times 4 is 16. 16 times 4 is 64. And then 1 times 1 times 1 is just 1, 64. Okay, that was a lot. Why don't we go into some problems now? This will be the first example, right? And the problem is up here. So in the problem, we have number 1. We have a few directions. Just give me a second. Okay. Find the root and simplify the expression. So here we have 64, and then we have a little like symbol, and then we have 1/3. Why did I use this symbol, right? This 64 raised to the 1/3. This is really just 64 1/3. But whenever we're writing things on the computer, right? Or whenever you're typing something into a calculator, you'll see that they use this form right here. They use this little caret sometimes, and that little caret just means that it's that the 64 is being raised to the power of 1/3. 1/3 is a fraction and it's together. That's why it's in parentheses to separate it out, right? So this is just like another way of rewriting that same problem, but it's the same problem that we've been doing earlier, right? So the first step to finding the root and simplifying the expression, because this is an expression, is to convert it from exponent form to radical form. That's step 1. So pretty much, let's see. Okay. 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 So pretty much we have 64 raised to the 1/3 power, right? And this will turn into root 3 over 64 to the first power. Because remember, this denominator is going to be your root, and it's going to be your root, and this 0 is going to be your power. And likewise, in the radical form, your roots goes on the outside, right? Okay, your root will go on the outside, right? And your power will be next to your base, your 64. That's what it means to convert from exponent to radical form. That's all I did. So I show that in this step right here, right? The next step, once you've shown that you can convert from exponent form to radical form, you're going to move on to step 2, which is you're going to take the root of the radicand. Remember, the radicand is just a number that's inside, right, of the little radical symbol, right? It's the 64, right? And you're going to have to take the cube root of it. In other words, you want to break it up into 3 numbers, right? That will equal that will multiply by itself to equal 64. That means that you're going to have to break it down into 3 different numbers that all multiply to give you 64. Now, in this case, it happens to be 4, right? If you're ever like wondering what's the fastest way to figure out these numbers, practice is honestly the fastest way. Um, you could always start low. You can always start. You'll start once you start practicing your perfect roots and perfect exponents. You'll see that there's a pattern, and you'll know which ones are going to be useful and which ones are not. So in this case, we have 4 times 4 times 4, right? Because 4 times 4 is 16, times another 4 gives me 64. So I know that the cube root of 64 is just 4, right? That's what I tried to show here, but it can be difficult when you type it out. So this was my best attempt at typing that out. Excuse me, this is dying for a second here. Okay. So with that in mind, uh, my answer is just that, right? 64 raised to the 1/3 power is going to be 4. And if you notice something, 4 is smaller, right? It's smaller than 64. And why does this make sense? Because when you raise something by an exponent, when you raise a number like 64 to a power, you expect 64 to be multiplied by itself. So it would get bigger, right? But in reality, you're multiplying it by a fraction. And whenever you multiply a whole number by a fraction, you usually end up getting a smaller number. Well, this is no different, right? This is the same principle of that. And it's why when you take the root of something, you also get something smaller. It's the same process. Okay, so why don't we move on to a more complicated problem, right? You're more going to be more likely to see something like this. Now we have 81 raised to the 1/4. Uh, so let's do that. 81 raised to the 1/4 power, right? Plus 9 raised to the 1/2 power. And you're expected to be able to solve this. Now, what you have to remember, right, is you have to convert each individual expression on their own from exponent form to radical form. Why? You might be wondering, if I can go from exponent to radical form, and radical form to exponent, why do I need to change it? If I know that the bottom is a root and the top is a power, can I just skip that conversion step? And the answer is no. Don't skip it. Yeah, I mean, I suppose you could do it if you once you get good at these and you can do these mentally. I suppose you could, but I want to see you converting all of the problems in your work. This is called showing your work. If you don't show your work on your papers, on your if you don't show your work on your work that you're going to turn in, then I'm not going to be able to give you credit. That's just something that you got to get used to in math. You got to show every single step. So with that in mind, convert every single time. So in this case, our first step should always be convert the individual expression from exponent to radical form. Unless the directions say convert this radical form to exponent form, you should always start this way, right? If it says to do it the other way, do it the other way. In this case, 81 to the 1/4 is being converted, right? To the 4 on the outside, the 8 and the 1 on the inside, plus, right? Let's see, a 2 root 9 1. And I put the brackets there just to let you know that I'm solving each one separately first. I'm reducing it to its most basic part first, so that once they become regular numbers, I can just add them at the very end. So adding should be the last thing I do. So right now I just did step 2, right? I did step 1, which is convert, which is this, right? Once I converted, I need to take each root separately. So in other words, what number multiplies by itself 4 times, 1, 2, 3, 4, to get 81, right? In this case, that happens to be 3. Again, how do you know where to start? I would always start with like multiples of 2 or multiples of 3. So the trick that you can do, like you can always put this in the calculator. You can always put like root 4 into the calculator. But if you're trying to figure this out by hand, you can always start with 2 and 3. Because what ends up happening is odd numbers are there's going to be some kind of root of 3 involved, probably. Um, it's very easy to figure out. Even numbers, you're going to have some kind of root of 2 at some point. And that may not be true for like prime numbers, but we'll deal with prime numbers at some other point. Um, for 81, all I did was I started with 3 because 81 is an odd number. I said, okay, let me start with 3. 3 times 3 is 9, right? And then another 3 times 3 is 9. So I have 2 nines. And 9 times 9 is 81. Okay, cool. So that means that 3 is my root. And what about 9? Well, I know 3 times 3 gives me 9, and there's only 2 of them that I need to do, right? So the square root of 9 is also 3, right? Just like the quad root of 81 is also 3. So now that we know that each side is 3, all I have to do is add them together. 3 plus 3 is 6. So the answer to the whole problem up there is just 6. And that's it. Okay, so with that in mind, we're going to move on to more complicated problems now. So please make sure you're writing down all these steps. Please make sure you have everything, because what happens is a lot of the times you think you understand it because it looks simple, but then you might forget because you do something else. And then if you have them in your notes, you can always look back to them without having to come back to this video every time. Okay, so moving on. Simplifying numerical expressions with radical exponents. So here we have a similar type of problem, right? Number one is very simple, right? However, we have 27 raised to the 2/3. What happens when you don't have a 1 in the numerator, right? So that's what I said here. I wrote my note. Notice that there's not a 1 in the numerator, which means that you're going to have to take the root of something, and then you're going to have to raise the answer to that in an exponent. So it's just an extra step, really. It's all it is. So right here, we have 27 raised to the 2/3. Let me write that in this form, right? We're going to change that to the radical, right? This is my root. This is my power, which means if I'm going to turn this into a radical, my root goes on the outside, that's 3. The main number, the base, goes on the inside, and the power sticks right next to it, right? So convert it to radical form, right? Once it's converted to radical form, right, you're going to want to take the root first. Why is it important for you to, could you do it the other way? Could you take the square first and then take your root? You could do that, yes, and you would get the same answer, except it's harder to do that. Because what happens is 27 times 27 is going to be a really big number, and then you're going to have to figure out what number multiplies by itself 3 times to get that really huge number. Or what you could do is you could just reduce 27 first. You can just find out what number multiplies by itself 3 times to get 27. In this case, happens to be 3. And what ends up happening here is you take one of those, and this square just kind of goes on to the new base, right? Once you've taken the root, once you've done this, you've taken the root, the square root goes away. You have a 3 square, right? And then now you can just do the exponent. This is just 3 times 3, which gives me 9, right? And that's what I wrote down here. I just kind of did every single step, right? And everything is written out so you have it in a much neater way, because a lot of people have told me that my handwriting is terrible, and frankly, I agree. So this is everything typed out. Hopefully that's a little bit more clear to you. Okay, cool. So that shouldn't be too bad. But what about number 2? Number 2 is, what if you have 2 of these and you have to add them at the end? What do you do? Well, you're going to do a lot of the same. You'll notice that there's a pattern to these problems. Here we have 4 raised to the 5 halves plus 4 raised to the 3 halves. And we're supposed to add these, right? We're supposed to add these, which means that we have to figure out each one separately. I'm going to just convert them really quick uh, to radical form, right? Then I'm going to take the roots, right? I'm going to focus on these first. So I'm going to make it smaller. So the square root of 4 is going to be just 2 to the power of 5, plus the square root of 4 again is going to be 2 to the power of 3. Right. So once we get to this point, right, once you figured out what the roots of your expression is, you need to do the exponent, right? 2 to the 5th power is just 2 times 2 times 2 times 2 times 2, right? Right, which is just 4. This is 4. This is 16. This is 32. Or you could put that in your calculator too, which will give you 32, right? So 32 plus, and the other one is just 2 times 2 times 2, 4 times 2, 8, which gives me 40. And everything, again, is outlined right here. If my writing is too difficult to understand, I suggest you copy down the typed version. And that way you're seeing both versions of it. All of these things equal each other. There's just a different way of writing, right? These problems. You might see it in this way, right? In some of the worksheets. You might see it in the typed out way. So I just want to make sure I prepare you for what these kind of problems are, right? Okay, so now we're going to move on to something a little harder, right? A lot of students end up struggling on these problems specifically. All right, other students have told me that these are the hardest problems. They get the other stuff, but when they run into like a fraction and they're just like, what do I do? It's a fraction from the beginning. It's a radical being divided by another radical. I don't know what to do, right? Or when there's multiplication and a negative exponent, what do I do? Or there's parentheses and more fractions. You know, this is how you deal with each one of those situations. Now, what I will say about the more complicated problems is you might have to do a version of each one of these steps in some of the larger problems, as like for next week and the week after. Like the problems are just going to get more and more complicated, but you have all the tools you need to solve them. You just need to remember what to do whenever you see a certain thing. So for example, how to deal with division with a radical expression, right? So in this first problem right here, oh, what happened? Okay, I'm really getting annoyed with that. My computer's being weird. Okay, so we have 25 raised to the 1/2 power divided by 27 raised to the 1/3 power. Another way of this could be shown, right? And when most students see this, they're just like, I don't know what to do. I don't know. So there's a fraction, there's exponents, there's a lot of stuff on there. What do I do? The first thing is you got to change it to a more familiar form, right? Um, you're going to want to change this from the numerator and the denominator separately into radical form. So the numerators first, just so you know, in case you don't know, the numerator that I keep saying is the number on the top of the fraction, and the denominator is the number on the bottom of the fraction. Just wanted to clarify. Every time you see like an N or a D written out, it just means I didn't feel like writing out the whole word numerator and denominator. That's what they represent. So here we have 25 raised to the 1/2 power. That's 2 radical 25 raised to the 1 power divided by 3 radical 27 to the first power. Once they're in this form, it looks a little, in my opinion, a little better, right? Um, some of you might disagree, but for step two, once you have it in radical form, right, you're going to want to take the roots, right? You're going to want to focus on this. So what number multiplies by itself to give me 25? Well, 5 times 5 gives me 25. So the top, the numerator, is going to be 5. And the denominator, 27, what number times itself will give me 27? Well, if you were paying attention in the last problem, this would have been 3. So now we have 5/3. Our fraction is as simple as it can be. If for whatever reason we ended up getting um, a fraction that can be simplified, like for example, I know we didn't get this, but what if we got something like, I don't know, 5/10, right? Let's pretend that this was our answer for a second. We could always simplify this because 5 and 10, right? The top and the bottom can be divided further, right? Can be divided by 5 to give me 1/2. And then this would be our final answer. It's always important to simplify whenever possible. But our actual answer here, 5/3, right? There's nothing that 5/3 can be divided because 5, and there's nothing that you can divide 5 by that you can also divide 3 by without, making them into decimals. So it's already in the simplest form. Um, some people might want you to convert this because the number on the top is bigger than the number on the bottom. When the numerator is larger than the denominator, they want you to turn it um, into a mixed number. we're not going to focus on that right now. And in part because it's also a way to know if you just looked up the answer. See, I want to see the specific steps that I'm showing you here in the work. And because it's really easy to try to punch some of these problems into a calculator and have it solved for you, but that's really not going to help you in the long run. So if I see something that I didn't teach you, I'm going to first ask you to explain it. And if you can't explain it, you don't get the points. And if that's just it's just a way to make sure that you're actually paying attention to what's going on. Make sure you do it like this. Leave it in that form. Don't worry about mixed numbers for now. So next part, how to deal with multiplication and radical expressions. Okay, so here we have a different kind of problem, right? In the past, we saw that it was like adding, right? Adding two expressions. Here we're multiplying two expressions. By the expressions, I mean there's a regular number. There's 7 times 10 raised to the negative third power. Um, okay, so first things first, recognize that the base 10 is being raised to a negative exponent, meaning you need to flip the numerator and denominator to get rid of that negative. Okay, so we're gonna ignore the 7 for now. So I know that this is the situation, right? Um, let's see, I'm gonna erase that. Jeez, okay. Okay, fine. I will not do that. So we have 7 times 10 raised to the negative third. Now, what happens here is, as I explained, in the very beginning, um, 10 raised to a negative power, we can't have a negative power. And what the 10 essentially translates to is 1/10 raised to the third power. They're the same thing, but we want to deal with the one that's positive, right? So really, we have 7 times 1/10 to the third power. That's what you should be doing first. You should convert it into a fraction and then flip it, right? Numerator becomes denominator, denominator becomes numerator. Once they're flipped, you can multiply, right? You can start multiplying the exponents. In other words, resolve the 10 raised to the third power. 10 raised to the third power is the same as saying 10 times 10 times 10. Which of course gives us 1,000, right? So at this point, we still have that 7 on the other side. We have 7, right, times 1/1,000. And whenever we're multiplying fractions, the rule for multiplying fractions is if you're multiplying a whole number like 7 by a fraction like 1/1,000, you need to convert 7 into a fraction. And we do that by just putting a 1 underneath it. Right? That's all we're doing. And now that we're multiplying, the rule is very simple. Multiplying fractions, numerator times numerator, denominator times denominator. In other words, 7 times 1 is just 7, and 1 times 1,000 is just 1,000, which means that we're left with our final answer, 7/1,000. Now, do we need to simplify this answer? No, because there's nothing that I can divide 7 by that I can also divide 1,000 by. So it's already in the simplest form. It looks weird, I'll give you that, but that's it. That's our answer. Right? I'm allowed to have a fraction as my answer. Okay, so hopefully that wasn't too bad. But now we're going to get into like the harder versions of these problems, right? How to deal with fractions with parentheses. Now, those are my lovely attempts to draw parentheses there. 1/4 parentheses raised to the 3/2 power. That is your problem. And your job is to reduce it to its simplest form, right? So step one, whenever you have a fraction that's inside of the parentheses and the whole thing is being raised by 3/2, what that's really saying is the entire fraction is being raised by the power, which means you're going to have to distribute the 3/2, your exponent, to the numerator and to the denominator. That's what step one is saying. In other words, that 3/2 becomes the exponent for the number 1 for the numerator. So it's 1 raised to the 3 halves power, and it's also 4 raised to the 3 halves power. Okay. Okay, so hopefully you're with me so far, right? It just all that happened was this went to the top and this went to the bottom. That's it. That's all I did, right? Because that's what the parentheses means. The parentheses means that the whole thing is being raised. That means each one is being raised by that. Once you have that, you're going to have to change the numerator and denominator from exponent to radical form. I just did that here. And to make it look what it looks like, right, we have 1 raised to the 3 halves power divided by 4 raised to the 3 halves power. And all I did was I just converted it to radical from exponent to radical. That's so weird. Yeah, I need to figure out what's wrong with this thing. Okay, so with that, we have 2, 1 raised to the third divided by, we have 2 raised to the 4 thirds. Honestly, okay. There. All right, so we have that. Once I transformed it in there, it makes it much easier to just do the radical, right? So at this point, this needs to be solved first, right? So in other words, the square root of 1, in other words, 1 times 1 gives me 1. So, I mean, 1 qualifies, right? And then 2 times 2 gives me 4, which means that it's going to be 2 raised to the third. Notice the power is just kind of hanging back. We're going to deal with the power after, right? Once we found the root of the numerator and denominator, we're going to move on to step 4, which is find the exponent of the numerator and denominator. This is just 1 times 1 times 1, and which just gives me 1. And this one's 2 times 2 times 2, which is going to be 4 eighths, right? So that's shown over here on the side, right? In case you were too distracted with my handwriting, all the steps are written out right here, right? So I wrote simplify if needed for step 5. I don't need to simplify in this case because it's already in the simplest form. But if there was like a 2 instead of an 8, I would definitely have to simplify, right? Okay, cool. So that's what it looks like to deal with parentheses. There's just one more complexity, right? I swear this is the last problem, I swear. Okay, how to deal with fractions raised to a negative exponent. All right, same problem. The only thing I changed was I put a negative in front of the exponent. So it's 1/4 parentheses raised to the negative 3 halves. All right. Step 1, the entire fraction is being raised by a negative power, so you need to distribute the exponent, the negative exponent, to n to the numerator and the denominator. Like in the previous problem, this goes to the 1 and this goes to the 4. Problem, it's a negative, which means that we need to get rid of the negative, which means that we need to change the numerator and denominator from exponent to radical form, and then we're going to flip them. I guess you could argue you could flip them and then change them to radical form. The point is that the numerator and denominator have to flip to get rid of the negative, right? So what I'm going to do is I'm going to change them first, right? So I have 1 to the negative 3 halves over 4 to the negative 3 halves. I'm going to change them form first. So I have negative 2 radical 1 third. And then I have, what was that, negative 2 radical 4 third. Okay, there you go. These two have to just flip. I would recommend you flip them first. It makes much more sense to flip them over there in this section. You just can't forget. You know, that's all. That's my point. They have to switch places at some point. Remember, this is a shortcut that I'm showing you, right? So when they flip, we end up with on top, and we end up with on the bottom, right? So Now that we've gotten rid of the negative and the numerator and denominator have flipped places, right? We just have to solve the radicals. And as with the previous problem, at this point, we've gotten rid of the major difference. So it's going to come out pretty much the same with just one major exception. So this is going to end up being 2. Hey, that looks familiar. Look at that. Your answer, when literally the only thing I changed was the negative in the exponent. And because of that, we ended up with 8 over 1. Now, 8 over 1, reduce the fraction if necessary. In this case, you would have to reduce it by just getting rid of the 1. 8 over 1 is just 8 divided by 1, which is just 8. So your answer at the end is just 8. The answer to that complicated thing is just 8. Okay, so this is a good place to stop. Next week, we're gonna be dealing with, we're gonna deal with all this, but just in a more complicated way. So good luck. Please, please, if you're having trouble, email me, um, contact me. Don't stay quiet. If you don't communicate with me and you don't let me know what's going on, I can't help you. Right? If something is going on, please let me know. Email me at uh, dpalacios at uh, laed.org. I will put my email in Google Classroom. You can send me messages through the private chats. You can ask whoever is at the school that you're at to communicate with me as well. Um, just communicate if you need help. All right, that's it.